Here we're jumping over to section 2.5, where we're going to study power equations and quadratic equations. So we're going to have more versatility with dealing with different types of equations. So we want to start first by looking at power equations. First of all, we want to talk about what is a power equation. Definition here, a power equation is an equation that may be written in the following form. X to the n equals a. X to the n equals a. So x is a variable, n is a whole number, and a is any real number. So a could be positive, a could be negative, a could even be 0. So you have x to a power equals a number. X to a power equals a real number. That's a power equation. So let's look at some examples of some power equations. Samples of power equations. We'll learn how to solve these. The first example here I have, let's see, x cubed equals negative 8. So what this is asking, what number x, or what numbers, maybe it's more than one number, can I cube and get negative 8? And if you think about it, there's really only one number you can multiply together 3 times, right? 1, 2, 3 times to get negative 8. And that single number is negative 2. So we're going to say x equals negative 2. So if you think about what actually happened here, essentially what I've done, I've written down an x, right? And I have an equal sign. And then what I've done, I've taken the cube root of negative 8, to get negative 2 for my answer. Okay? Now let's do another power equation. Let's say we have x squared this time. X squared equals positive 9. X squared equals positive 9. So think about what number do you have to square to get positive 9, or what numbers, maybe it's more than one number, do you have to square to get positive 9? So 2 numbers you multiply together to get positive 9. You could do 3 times 3. Get that right? So I got positive 3 is an answer. But also I could do negative 3. I could square negative 3. Negative 3 times negative 3 to get 9. So plus minus 3 are your solutions. You actually have two solutions. So if you think about how we actually went about getting that, for solutions, plus minus 3, we have an x, right? And then what we have is a plus minus. And then we just took the square root of 9. The square root of 9 gave us the 3. So we got plus minus square root of 9. So that's plus minus 3. Okay. So that's when you have, notice the power here is even. And the number on the right side, the 9 is a positive number. So x to a power equals a number is a power equation. One more. What if I add x squared equals negative 100? So it's impossible, right? It's impossible to square anything and get a negative number. It's impossible to square real numbers anyway. You can invent something called imaginary numbers. We're not doing imaginary numbers. So anytime you have an even power and a negative on the opposite side, you're not going to have a real solution. So there's no real solution. There's something called an imaginary solution to this, but we're not getting into imaginary numbers, so there's no real solution. Right? You can't square a positive, a negative, or 0 to get negative 100. So these three cases here we have lead to some important facts about power equations. So I'm going to write solutions to power equations. There are three types of solutions that can show up. Solutions to power equations. So number one, if n is an odd power, then the power equation x to the n equals a has one solution. It's a solution of x equals the nth root of a. That was exactly like our first situation where we had x cubed equals negative 8, right? We just had one solution. So to get that solution, we dropped the cube, right? We dropped the cube on the left-hand side of the equation, and we took the cube root on the right-hand side. So if you have an odd power, you just drop the power on the left-hand side on the x, and then you take the root of the right-hand side. All right, a second situation that can show up. Number two, if n is an even power, and a is positive, capital A, positive, then the equation, the power equation, x to the n equals a, has solutions. It has two solutions. The solutions being x equals plus minus the nth root of a. So that was like in our second situation. Our second situation where we had x squared equals 9, right? We had an even power, and on the right-hand side we had a positive number. So to solve that, basically we dropped the square on the left-hand side, the square above the x, and we did plus minus the square root of the right-hand side, square root of 9 being 3. So plus minus square root of 9 is plus minus 3. So two solutions. And then there's a third case. A third case we need to mention. What could happen with solutions here? Let's say n is an even power. If n is an even power, and the a, that's the right-hand side, is negative, then the power equation x to the n equals a has no solution. And that's exactly like the situation in 3 above there when we had x squared equals negative 100, right? You can't square a number and get a negative. You can't square a real number and get a negative. I should say here no real solution. Not no solution, but no real solution. That's the correct way to say it. Yeah, so you can't raise a number to an even power and get a negative. All right, so 3 situations to be concerned with when you're solving power equations. You can get one solution, you can get 2 solutions, or you can get no real solution. All right, so let's solve some power equations. Let's just do some exercises. So these are all going to be power equations. Some of them may not look like it, but we can rewrite them so that they will look like power equations. So solve the equation. Those are instructions. number 1. Let's say I have 2x cubed equals 54. Now, right now, that may not look exactly like a power equation. It may not look like x to a power equal a number. However, we can make it into, and right, it got that 2 out front of the x cubed, 2 out in front of the x cubed, so we want to get rid of that 2 that's multiplied by x cubed, so we're going to divide both sides by 2. So here the 2's will cancel, and we're going to get x cubed equals, what's 54 divided by 2? 54 divided by 2 is 27. So using our solution rules for power equations, rules for getting solutions, when you have an odd power, in this case, this guy is odd right here. 3 is odd. We're just going to take the cube root of the right-hand side. So you drop the cube on the left, and take the cube root of the right-hand side. You don't have to put a plus or minus. Plus or minus is only when you have an even power. So you're just going to take the cube root of 27, which we know is 3, right? Cube root of 27 is 3. All right. Here's a number 2. This time we have z squared minus 121 equals 0. So right now it doesn't look like a power equation, right? It's not x to a power equals a number, or in this case z to a power equals a number. But we can do that. We can get it that way, to get z to a power equals a number. So notice you got this connection minus 121. Let's get rid of that minus 121 connected to the left side. Let's add 121. Add 121 to both sides. So when we do that, we're going to have, let's see, z squared on the left, negative 121 and positive 121 cancel. We're going to have equals. On the right, 0 plus 121 is going to be 121. So now it's very clearly in the form that we want for a power equation. Now notice that the power here, the square, is an even power. So if I wanted to solve that, how would I do that? Well, I go to rule number 2, right? We got an even power and a positive number on the right. So I'm just going to copy down z and drop my square. So I drop the green square. And on the right-hand side, I have to do plus minus. Remember, plus minus when you have an even power. Even power requires a plus minus, then the square root. So plus minus the square root of the right-hand side, 121. So we're talking about z is 2 solutions, plus minus. What's the square root of 121? How about 11? So you get 2 solutions, plus 11 and minus 11. So you should expect to get 2 solutions when you have even power. Even power showing. All right, number 3. How about 3y squared plus 2 equals 14. So that is not a power equation. Well, actually it is. You might think it's not. It actually is. It's just in disguise. So you just have to rewrite it. You have to rewrite this equation so you can recognize it as a power equation. So basically we want to get the y squared by itself. So first we're going to undo the addition by subtracting 2 from both sides. So we're going to have 3y squared, 2 and negative 2 cancel on the left. On the right, 14 minus 2 is 12. And then we got to get rid of that multiplication by 3 on the front of y squared. So we're going to divide both sides by 3. 3's will cancel here, and we'll get y squared by itself on the left. Equals, what's 12 divided by 3? It's 4, right? 4. So again, we have a power equation. This time y to a power equals a number. Notice that the right-hand side is positive. The left-hand side has an even exponent. So to solve this, we're going to copy down the y. We're going to drop the exponent. We're going to write an equal sign, and we're going to do plus minus, right? Plus minus. You do plus minus when you have an even power and a positive on the right-hand side, plus minus the square root. Plus minus the square root of the right-hand side. So all we have to do here is figure out what the square root of 4 is. So y equals plus minus, square root of 4 is 2. So plus 2 minus 2. Those are your two solutions to this equation. All right. Let's do a number 4 here. Nope, that's not 4, is it? That's 6. All right, here we go. We got 5x squared minus y. And all of that is divided by 4. All of that is divided by 4. And we want that equal to 31. Now notice here that we got this fraction. So remember, anytime you have fractions, in an equation, you want to get rid of your fractions. So you find an LCD, which here in LCD is 4. That's the only denominator. And we're going to multiply both sides by the LCD. So I'm going to multiply by 4 on this side. I'm going to multiply by 4 on that side. Now this is understood to be 4 over 1. 4 over 1. So what happens? Well, basically the 4's here cancel. 4 on top cancels with 4 on bottom. We're left with 5x squared minus 1. Then on the right-hand side, we're going to do 31 times 4. 31 times 4 is going to be 124. So that got rid of our fraction. Now, we want to get the x squared by itself. So first we're going to get rid of that minus 1. So we're going to add 1 to both sides, which leaves us with 5x squared equals 124 plus 1 is 125. And then we have to get rid of that multiplication by 5 there in front. So we're going to divide both sides by 5. Whereas the 5's will cancel, and we'll get x squared equals, what's 125 divided by 5? Well, it's 25. Again, this is an even power. Wow, we're getting a lot of these even powers. Even power, so we're going to copy down the variable, write an equal sign, and then we have to remember when we have an even power, we're going to do plus minus, in this case, the square root of the right-hand side, 25. So we're talking about plus or minus. Square root of 25 is 5. So two solutions. 5 and negative 5 will satisfy this equation. You could actually check these if you want. You can plug 5 in and check it out, and then plug in negative 5 and check it out. We'll do that for one of these later. Maybe the last one. Number 5. How about we got 3y squared plus 192 equals 0. So let's get this in the standard form for a power equation where we got like y to a power equals a number. So first I want to get rid of the 192 that's added, so I'm going to subtract 192. It's going to leave me with 3y squared equals negative 192. Okay, now we want to get rid of that multiplication by 3 on the front of the y squared, so we're going to divide both sides by 3. The 3's cancel on the left, and let's see, we're going to have what? Y squared equals, what's negative 192 divided by 3? Let me pull out a calculator here. I believe it's minus 64. Let's see. Get a calculator. Negative 192 divided by 3. Negative 64. Now, you might say, hey, we got an even power here, which you're correct. We do have an even power. But the right-hand side is not positive. So actually, when you have an even power and the other side, the right-hand side, is negative, you're going to have no solution. Right? You can't square a real number and get a negative. It's impossible to square a real number and get a negative. And that was this third case right here, right? This third case that we talked about, when n is an even power and the right-hand side is a negative, a is negative. No real solution. Okay, so be aware that sometimes that'll happen. Actually, those problems are less work, a little bit less work. Now, I shouldn't just say no solution. I really should say no real solution if I want to be 100% correct, because there is actually a solution out there called an imaginary solution, but there's no real number that's a solution. So no real solution is how I should say it. Okay, better. All right, so we want to do one more problem. One more problem. Here we go. How about we got 2z plus 5 quantity squared. So all that's squared. The z plus 5 is squared. So z plus 5 is in parentheses. That's squared. Minus 1 equals 71. So you want to treat this like a power equation. And you want to think of the z plus 5 here like a single entity. You want to imagine that z plus 5 is like an x there. Imagine that this whole z plus 5 is like an x. So you want to get the z plus 5 by itself, basically. So what I'm going to do, if I want to get z plus 5 by itself, first I'm going to add 1 to both sides to get rid of that minus 1 on the left side. That's going to leave me with 2 times, in parentheses, z plus 5 squared. Okay, the negative 1 and the positive 1 cancel. We get equals, what, 71 plus 1 is 72. Okay, so remember, our object here is to get z plus 5 by itself. So we have to eliminate, before we eliminate the exponent of 2, we have to eliminate the multiplication by 2 in front. So we're going to divide both sides by 2 here. That's going to cancel the 2 there in front. So now we'll have, in parentheses, z plus 5. To the second power equals, what's 72 divided by 2? 72 divided by 2 is 36. So we want to think about the z plus 5. Imagine this is just an x. Z plus 5, the whole thing is an x. So how would you solve like x squared equals 36? Of course, you have an even power and a positive on the right side. So what you do, you write down your x, which in this case is z plus 5. You just copy down z plus 5. You drop your power. And since it's an even power, remember we have to put plus minus square root of the right-hand side, 36. So that's going to give us z plus 5 equals plus minus, what's the square root of 36? Well, 6. Okay, so we got z plus 5 by itself. That was our big push to get z plus 5 by itself. Now we're not entirely finished. We have z plus 5 by itself. Z plus 5 is equal to plus minus 6. So now we have to get z by itself. So here we're going to subtract a 1 from each side. I'm sorry, subtract a 5. Subtract a 5, so I'm going to minus 5 from each side. So when I do that, I'm going to get z all by itself, finally, equals negative 5 plus minus 6. So that's two different numbers. Let's break it into a branch. So first of all, I have z equals negative 5 plus 6. And that's one situation. And the other situation, z equals negative 5 minus 6. Yep, so you got the plus 6 here and the minus 6 here. So first I'm going to take negative 5 plus 6. Negative 5 plus 6, that's going to give me 1. So that's one of my solutions. And then I'm going to take negative 5 minus 6. Negative 5 minus 6 is negative 11. So that's my other solution. So my two solutions would be 1 and negative 11. Let's go ahead and check we haven't checked any of these. Let's go ahead and check this one, just to make sure. So I'm going to check my solutions. So first I'm going to plug in 1 in for z into the original equation. So I'm going to have 2 times blank plus 5 squared minus 1 equals 71. So first I'm going to check by plugging in 1 for z. 1 for z. So I'm going to put a red 1 right there. So we want to do order of operations. So when you're doing order of operations, first you do what's in parentheses. So here I'm going to add 1 and 5. 1 and 5 here is going to give me 6. Okay, so after you do 1 plus 5 in parentheses to get 6, then you have to do exponents. Exponents come before multiplication. So I'm going to leave the 2 out front alone. I'm going to do 6 squared is 36. Everything else will stay the same. And then I do multiplication before subtraction. 2 times 36 is 72. I have 72 minus 1, 71. That's correct, right? That's correct. 71 equals 71. So 1 checks out. Z equals 1 checks out. Let's try z equals negative 11. So I'm going to take my equation and plug in negative 11. So I'm going to have 2 blank plus 5 squared minus 1 equals 71. So in place of the z, I'm going to put a negative 11. So I'm going to keep the 2. I'm going to keep the square. I'm going to keep the minus 1 equals 71. And I'm going to do what's inside parentheses first, right? Please excuse my dear Aunt Sally. So first you do what's in parentheses. Negative 11 plus 5. Negative 11 plus 5 is negative 6. So next, according to order of operations, you would want to do exponents. So you're going to leave the 2 out front alone, and negative 6 squared is what we're going to work on. So negative 6 to the second power is 36. Right, negative 6 times negative 6 is 36. And then according to properties of order of operations, rather, 2 times 36, we do multiplication before subtraction. 2 times 36 is 72. 72 minus 1, 71. Yes, it is. We get 71 on the left, 71 on the right. Checks out. So yeah, both of those solutions work. You can check all of your answers here that they work out, but I'm just doing this last one. Of course, I don't expect you to check your answers. You don't have to check your answers. You don't have to ever check your answers when you're doing quadratics. All right, I think I'm going to quit there on power equations, and then the next video, we're going to start looking at quadratic equations.